In example 5, our polynomial function is f of x is equal to negative 2x squared times the quantity x squared minus 2. All right, let's start breaking this down. So we can rewrite this as negative 2. X squared is going to be x times x. And then when you look at the x squared minus 2 in parentheses, remember that quantity is raised to the first power, so you can't break that down any further, okay? If you had an exponent on the outside, like a 2, then you would have to write the quantity x squared minus 2 twice, okay? But since you don't have an outer exponent, you're just going to have to leave it like this. All right, so let's try to determine the leading term here. So what I'm going to do is I'm going to go and highlight everything that has an x. Okay, so I've got x, x, x squared, and then I've got to highlight the number that's in front. Okay, so that's negative 2. And so now I'm going to multiply all these guys together, and that is going to give me my leading term. Okay, so we're going to have negative 2 times x times x times x squared. So the number out front will be negative 2, and then you're going to add the exponents on the x's. So it's going to be x to the 4th power. So the degree is 4, and the leading coefficient is negative 2. Okay, so we've got an even degree and a negative leading coefficient. So we're going to be able to determine the end behavior. Okay, if you glance back at page 4, we'll look for even degree, negative leading coefficient. Our polynomial is going to behave like negative x squared. It's going to fall both to the left and to the right. It's going to behave like negative x squared. Okay, so let me write that out to the side. Our polynomial is going to behave like negative x squared. Okay, so that looks like this. Okay, so when we draw our polynomial, it's got to fall left and fall right. Okay, so if we have to write our end behavior all mathy, first thing we're going to do is describe what happens as your x values approach negative infinity. As your x values get more and more negative, their y values get more and more negative. Okay, so as x approaches negative infinity, the y values also approach negative infinity. And then you need to look in the other direction. So as your x values approach positive infinity, so as your x values get more and more positive, their y values also get more and more negative. Okay, so we'll write as your x values approach positive infinity, the y values approach negative infinity. Okay, so again, to write this mathematically, as your x values approach negative infinity, the y values approach negative infinity. That's the yellow part. And as your x values approach positive infinity, your y values also approach negative infinity. That's the green part. Okay, you need both pieces. So we're falling left, falling right. You better see that in your graph when you do it. Okay. All right, so let's go on to zeros or x-intercepts. Again, if you encounter any kind of imaginary zero, we're not going to worry about it for now. Okay, so what I need to do here, okay, I'm going to come up here. I've got my function. It's negative 2 times x times the quantity x squared minus 2. Okay, if we're dealing with an x-intercept, we need to set y equal to 0. And so f of x is y. So we need to set that equal to 0, and we need to solve this. Okay, again, this is a higher degree polynomial. This is a 4th degree. Can't use quadratic formula on it, only on degree 2. Okay, so you would have to factor, but luckily it is factored for us. And so you see the factors, the things that you're multiplying together to get this polynomial. Okay, so you need to take each factor, set it to 0, and solve. Okay, so if we come down here, you could take negative 2 and set it equal to 0, but remember that doesn't make sense. You only need to take the factors that have an x and set them equal to 0. Okay, so I've got an x, that's my second factor. I'm going to set it equal to 0. There's nothing to solve. Okay, so we get that x equals 0 is going to be an x-intercept. Okay, so we've done this one, we've done this one. We've got another factor of x. Okay, so I'm going to set it equal to 0. Okay, nothing to solve again. And then, so we've taken care of this one. Now I'm going to go on to the x squared minus 2, okay, and set it equal to 0 and solve. Okay, so this is quadratic. Okay, when you're just looking at this piece, the highest power of x is the second power. So you can factor, use the quadratic formula. Another option in this situation is to move the 2 over to add 2 to both sides. You've got something squared equal to a number, so you can use the square root method on this thing. That's probably the easiest thing here, okay? So we're going to take the square root of both sides. Remember, you can't forget plus or minus out front, okay? So the square and the square root will cancel, leaving you with x. And your x-intercepts are going to be plus or minus out front the square root of 2. So you actually have two separate x-intercepts here. You've got positive square root of 2 and negative square root of 2. Okay, if you put that in a calculator, that's about 1.414. Just leave it as the square root of 2. Okay, but I guess when we do put it on the graph, you're going to have to know it's between 1 and 2. Okay, so let's go ahead and fill out the chart. Okay, the first x-intercept that we got was 0. Okay, remember, if we look at this, we got it twice. Okay, if you look at this, when I wrote it out, we got this x-intercept twice. So it's going to have multiplicity 2. Since this is an even multiplicity, our polynomial function here is going to touch or bounce. Okay, then from this next piece, the x squared minus 2 equals 0, when we solved that, we got two zeros. We got negative square root of 2, and we've got the positive square root of 2. So you might be wondering, you know, what's the multiplicity here? Because this is a little tricky, okay? This piece, we're concentrating on this piece, the x squared minus 2 equals 0, okay? The highest power of x in this thing is 2. That means it can produce at most 2 zeros, okay? So it produced the positive square root of 2 and the negative square root of 2. So those are your 2 zeros. They each have multiplicity 1, okay? So basically, I don't know if you remember, but we said if you have a polynomial of degree n, it can have at most n real zeros, okay? So we have degree 4. It has to have, you know, at most 4 real zeros. The multiplicity basically has to add up to 4. So we know the 0, the 0, x equals 0 has multiplicity 2. That leaves each of these guys to be multiplicity 1. So that your multiplicity 2 plus 1 equals 4. That equals the degree. Okay, and that actually happens every time. I'm going to flip back to the previous example, okay, really quick, when we had the imaginary zeros, okay, because I didn't talk much about that because they were imaginary. It was kind of our first encounter with imaginary zeros. But if you remember, we got an x-intercept of 2. It had multiplicity 3, and then we had two imaginary zeros. We had the negative I, which was a negative square root of 1, or wait, sorry, the negative square root of negative 1, and then we had positive I is a 0. And this was a degree 5 polynomial. So what happens here is both of these guys have multiplicity 1, okay? And then you do the 3 plus 1 gives you 5. The multiplicities add up to the degree of the polynomial, okay? And here these guys weren't on the graph, so you don't really deal with the whole issue of cross or touch because they're not physically present on the graph, okay? But the moral here is if you list out all of your zeros, regardless of whether they're real or imaginary, all the multiplicities need to add up to the degree of the polynomial, okay? So keep that in mind as you're doing this, okay? All right, so going back to our example that we're working on, we get these two different x-intercepts, negative square root of 2, positive square root of 2. Each one of those guys is going to have a multiplicity of 1, and so that's an odd multiplicity. So at both of these x-intercepts, the graph will be crossing the x-axis. Okay, all right, so that's it. Okay, part D, let's find the y-intercept. So we need to set x equal to 0 and solve. So let's go take a look. Go back up to your original function, and we're going to, substitute x equals 0. So we're going to get y equals negative 2 times 0 times 0 times 0 squared minus 2. Okay, Let's see, this is going to give us -2 times 0 times 0 times -2. Anything times 0 is going to give you 0. So your y-intercept is going to be at x equals 0, y equals 0. So the origin, okay, notice the origin is also going to be an x-intercept. Okay, we figured that out up here. All right, so one more thing in part E, and then we'll put this graph together. What is going to be the maximum number of turning points on the graph? Well, we have a degree 4, so you need to just take off 1. So we're going to take the degree minus 1. That's going to be 4 minus 1. You can have at most 3 turning points on this graph. Okay. All right, let's put all this information together. First thing we need to do is come up with a scale. So we know we have a y-intercept at the origin. So our y-axis, we don't really have to think too hard about that because it's not a big number here. And then our x-intercepts are at 0, and then positive and negative square root of 2. Again, square root of 2 is about 1.414. So that's just going to be somewhere between between positive 1 and positive 2, and then on the other side between -2 and -1. Okay, so I'm just going to keep everything as is. I'm just going to put tick marks every 1 unit. Okay, let's see here. So let's see, that's what I will do here. All right, so again, you can do whatever you want as long as you label it. So I'm just going to say this is 1, 2, 3, 4, 1, -1, -2, -3, -4. Okay, let's go ahead and put specific points. Okay, we know there's an x and a y-intercept at the origin, so the graph will go through there. And then we have x-intercepts at negative square root of 2 and positive square root of 2. Again, negative square root of 2 is about -1.4, and then positive square root of 2 is about positive 1.4. So you're just going to have to eyeball it. Okay, and that's all the specific points that we know. You don't have to plot anymore. Okay, we're just doing a rough sketch. Okay, like we don't know, we're drawing a shape here, but we really don't know how far up we're going or how far down we're going at any given x value. It's just a rough sketch. All right, so the next thing we have to do is abide by the correct behavior at the x-intercepts. At 0, we need to be touching. At the other 2 x-intercepts, we need to be crossing, and we also need to have the correct in behavior. We need to be falling left and falling right. Okay, so I'm going to go ahead and say we're falling left and we're falling right. Okay, we're going to have to, it looks like, well, okay, let's go from left to right. So we're falling left, okay, and so we're going down like this, like I've already drawn. We're going to have to come up, and we're going to have to cross at x equals the negative square root of 2. Okay, so we're going to have to cross here. We're going to have to come up and go back down here. Okay, now be really careful here. You do not want to create a cusp. Okay, because remember, you're touching or bouncing at 0. Okay, so you need to smooth it out. Okay, it's going to look like this. Okay, do not come down like that cusp. You don't want like a sharp corner or a cusp. You kind of have to round out and then go back up because you're bouncing or touching at x equals 0, and then you're going to have to come back and go through this x-intercept at the positive square root of 2. You want to cross there. Okay, and then you're going to have to go down, okay, so that you're falling right. Okay, this is not the best picture, but you can kind of get the idea of what indeed is going on here. So let me kind of fix this. Okay, so here we go. All right, so this is what it looks like. Okay, again, if you really zoom in on x equals 0, it's doing something like this. Okay, no cusp. Okay, I'll put this here. No cusp at x equals 0. Okay. All right, so let's make sure that we've done everything we need to do. Okay. First thing, we need to see that we're falling left and falling right. Okay, we are doing that. And then we have 3 real zeros here that we can see. So at x equals 0, we are touching or bouncing there. And then both at negative square root of 2 and positive square root of 2, we're crossing. Okay. And we have a y-intercept at the origin, and now we just need to check the turning points to make sure we don't have more than 3. So I'm going to trace the curve from left to right to see, where I change from increasing to decreasing or vice versa. Okay, so if you follow my cursor, I'm rising, so I'm increasing, and then when I get to the top of the hump, I'm going to start to decrease. Okay, so there's a turning point. I'm decreasing, falling, falling, falling until I get right here. Then I start to rise, and then I start to fall again right here. So there are 3 turning points, and that's okay as long as we don't have more than 3 turning points. Okay, so this is what our graph looks like. Okay, you could pop the original function into the calculator, graph it out. You should get a similar looking picture. Okay, just make sure you don't have a cusp at x equals 0. Everything's got to be smooth and continuous.